So here we have, at least for starters, a trig identity that we're just going to reduce. We're not going to get too excited about thinking of this as compound angles because they're just normal reductions. One thing worth highlighting is the 90 because that will always remind us to co-ratio. I like to highlight the 90s, or if there are 270s, first, so that I don't forget about those later, and also to remind me that the others reductions will stay the same as they are. If they began as sine, they'll be sine after the reduction. So I'm just going to draw a little cast diagram to come back to as I reduce each of them. So 180 minus is in this quadrant where sine is positive. Whenever you've got a 360, you can basically add 360 to that, and it just simplifies immediately as cos x. What's starting to buzz in my mind is whenever I see sine and cos touching each other, I'm thinking of the sine double angle. So let that buzz immediately. On the bottom line, that's still just sine squared, and then 90 plus changes from sine to cos. So it will be cos squared x. This is also buzzing in my mind because when I start seeing squares, I'm thinking normal identities like sine squared is 1 minus cos squared, or cos squared is 1 minus sine squared. But I'm also looking up here and seeing it's kind of like the cos double angle. It's just the wrong way around, and that's absolutely fine. It just means we do a switch around. So the top line, it's not exactly the same. It's 4 times bigger. So the double angle on the top line for sine will just be 4 times what it usually is. And on the bottom line, when we do one extra step and just take out a negative and do a switch around, like you did when you began factorizing, so that makes it look exactly like the cos double angle. And so I'll have 4 sine 2x on the top, negative cos 2x. Sine over cos is just tan. Be careful not to cancel out the 2x's. Just leave it as tan 2x. And there's a negative and a 4, so it's negative 4. And there we have proved our identity.